All right, we are looking at worksheet 60A. They're inverse trig ratios this time, so I called the 7-4 part 2B. The idea is I have all three sides of my triangle. I have the two legs, I have the hypotenuse, and we're trying to find a missing angle, so that's why they have that degree sign there. So if I'm looking for angle A, go ahead and circle that. That's what we want to see on your paper. Now, on the worksheet we did yesterday and other days, you had to use specifically sine, cosine, or tangent dependent on the information you're given. But if you're given all three sides, you can use any trig function you want. So if I want to use the sine function, and I'll do the sine function first, I need the opposite and hypotenuse. So if I'm using sine of angle A, I need the opposite over the hypotenuse. So that's my little O over H to remind me. So looking at my triangle, I want to label it. And so this is my hypotenuse. The side along the angle is my adjacent, and the side opposite the angle is the opposite. Now, it's all because I'm based on angle A. So if I chose to use sine of the angle, I would use the opposite, which is 12, over the hypotenuse, which is 20. Now, if I just asked you for the trig ratio, you would tell me 12 over 20, and you reduce the trig ratio, and you would tell me, well, they both divide by 2. Well, actually, they both divide by 4, so that'd be 3 over 5. And that was all we did before, was just the trig ratio. Then we took it a step further. Rather than just leaving the ratio of 3/5, I'm asking you to find me the missing angle. So I need to get rid of sine. Remember, sine A is a number. And how do I get rid of something? I use its inverse. So the inverse of sine A is the inverse of sine A. So you're going to use your inverse sign. That symbol, -1, tells me it's the inverse. And if I take the inverse of the sine, and I do the inverse of the sine over here, the left side cancels out and it leaves me A. And what I type in the calculator is sine -1 of 3/5, just like that. Now, I wouldn't take the time to rewrite that. I just did it because I wanted you to see. So in my calculator, I just have to hit, there's my sine key, and I would hit second and then sine, and there's my little inverse. So it'd be sine of 3 fraction 5, or 3 divided by 5, and hit enter. But it has to have the -1. And it says round to the nearest degree. So we want the whole degree, and that would be 37. So A is approximately 37 degrees. Okay, so I've got that. Now, real quick, if I have a different calculator, if I have the TI-34, I'm going to hit second in my probability key, because right above it, it says trig. And then if you see there's sine, inverse sine, cosine, inverse cosine, tan, inverse tan. So I want to hit enter. It's going to pop that up. I can hit 3 divided by or 3 fraction 5. That's up to you. And I get the same outcome. All right, so let's go ahead and do number 2, but let's use the cosine function. So I want to use the cosine of G. So take a minute and label that. All right, so if we're looking at the cosine of G, I'm going to circle that. And this is my adjacent, this is my hypotenuse, and this is my opposite. So when I'm looking at this, the cosine of G, if I'm using cosine, I'm using adjacent over hypotenuse. Here it is, adjacent over hypotenuse. So if I look at it, the adjacent is 32, the hypotenuse is 40. So typically you would be reducing this and telling me, hey, here's the ratio. I actually don't need to spend the time reducing it if I'm just using my calculator to solve it. But if you were just giving me the ratio, you would reduce that fraction by 8. I'm just going to come in and take the inverse cosine. So anytime I'm looking for a missing angle, I'm going to use my inverse. So this is going to cancel, and I'm just going to type in the calculator. I'm hitting second in my inverse cosine, or some of you second in the probability key. And then I'm going to type in 32 divided by 40, or fraction, and I get 37 again. All right. So G is approximately 37 degrees. All right, so I want to do one more with you on this side, and I want to use the tangent function. Now, you could use sine the whole way through, but I wanted to mix it up and use different functions. So if we're going to do tangent of C to find it, take a minute and label your triangle. This would be your hypotenuse because it's the longest side, opposite 90-degree angle, adjacent, and opposite. Okay, so if I'm using tangent, tangent is opposite over adjacent. So opposite 32, adjacent 24. Again, we don't have to reduce, but we typically would. I'm going to come in to get rid of the tangent. To find a missing angle, I'm going to use the inverse. So that cancels, and I get C is approximately. And again, as long as I'm showing that I'm taking the inverse, I don't need to rewrite it. That's your call if you want to rewrite it. So I'm using my inverse tangent, 32 divided by 24, or fraction. Okay, good. It's not the same number. I get 53, bless you. So about 53 degrees. So we did one of each type on the front, and you can see it's the same process. We just have to wash our ratio. Now, flip it over to the back. You don't have all three sides. That's a difference. And all of these, you could pick sine, cosine, or tangent, depending on which sides you want to use. But on the back, I'm forced to use a specific one. So circle your angle. This is my hypotenuse, and this is my opposite. Now, if I really wanted to, and this came up a couple times, if I really wanted to, I could use Pythagorean theorem. 36 squared plus b squared equals 45 squared. And I could find the missing side. But since I'm not being asked to solve the whole triangle, just find the missing angle, I have the opposite and hypotenuse, which leads me to use what? Sine. All right? So depending on what I have, and that's the SOH, so katoa, you can just reference that. The OH, I'm using sine. So I don't have an option here. I'm going to use sine of A, and that is the opposite 36 over hypotenuse 45. Now again, this fraction, 100%, that fraction reduces, but we're coming in, we're doing the inverse sine and using our calculator to find the measure of angle A. All right, so inverse sine, that's how we cancel it. The 36 divided by 45, close those parentheses, and I got 53. It seems like I'm getting some definite repeats today. 53 degrees. Okay, let's, I'm not going to do one more, but I just want to talk about one more. If I look at number 3, and I need to find the measure of angle B, I have the adjacent, remember this is your opposite, I don't know anything about it, and I have the hypotenuse. So which trig function do I have to use for number 3? If I have the adjacent and the hypotenuse, which trig function am I forced to use? Which one? Cosine. Absolutely. Now, if I wanted to, I could find the missing side using Pythagorean theorem. Especially if they ask me to find another angle, I might have to use Pythagorean theorem if I have to find both angles in the missing side. But I can use, you guys said, cosine of B, and that equals the adjacent 12 over hypotenuse 15. And absolutely, this fraction reduces, but we're going to jump into our calculators and do what? I said I wasn't going to do one more, but we might as well. The inverse cosine. So anytime you're looking for a missing angle, we've got to break that trig function off with its inverse. So go ahead and type that in the calculator. Second inverse of 12 over 15. And I get 36.869. It keeps going, so 37. Nearest whole degree is what it says. So 37 degrees. All right, this worksheet should not take you too long. You're really setting it up and using your calculator. I would like to see you circle your angle and label each triangle first, and then make sure you pay attention to which trig function you're picking.